All right, so square roots. Sometimes we call them radicals. All right? So a radical expression is an expression that contains a radical. Yeah, a square root symbol. That's what a radical is. A radical expression involving square roots is in simplest form when these three conditions are met. All right, no radicand. What's a radicand? You guys know? Radicand is the number or the term underneath the radical sign. So no radicands have perfect square factors other than 1. No radicands contain fractions. So if there's a fraction under the radical sign, it's not in simplest radical form yet. No radicals, no square root symbols appear in the denominator of a fraction. You know where the denominator is, Landry? Yeah, the bottom. What's the top called? The numerator, right? We all know that, don't we? It says you can use the properties below to simplify radical expressions involving square roots. All right, so you got the product property and the quotient product property. Product means multiplication, quotient means division. Okay? And our numbers are positive, it's say. Where A and B are greater than or equal to 0. Okay? And for the quotient property, B can't be equal to 0 because it's in the bottom. So it has to be greater than 0. So we're talking about positives right now. We won't have any negatives in the radicand. Now, eventually we'll get there with those. All right. So there's 2 examples. The square root of 75, and we'll just do that one first. All right, so we're supposed to put that in simplest radical form. All right. So I do what we call a factor tree. You guys remember how to do a factor tree? Yeah. Go ahead and start your factor tree. Cindy, tell me what to write. And it doesn't really matter how you start, it's just 2 numbers that multiply to give you 75. Okay, 15 and 5. So then 5 is a prime number. We're looking for the prime factorization, right? That's what we call this actually, prime factorization. And then all of you guys know 3 times 5, right? Now, to simplify this, I'm looking for pairs of the same number. Do I have a pair of numbers up there? Yeah, I got a pair of 5s, right? So whatever you have that's a pair of something, you can bring it out front of the radical sign. So I can bring that 5 out front. And then whatever's left stays underneath where the radicand goes. Okay, so that's the square root of 75 simplified in simplest radical form. 5 times the square root of 3, or 5 radical 3. You guys remember that from Algebra 1, hopefully? Yeah. Now, me, I would have done it this way. And I'd circle that. What type of number is 25? Got a special name. Starts with a P. P-R. Perfect square, yeah. So I look for perfect squares when I do my factor tree, because I know the square root of 25 is what? 5. So I don't go all the way down and make it 5 times 5. Whenever I see a perfect square, I circle it, and I know I got to pull a 5 out. But this may be a little quicker way. If you want to go all the way down to all the prime numbers and then circle your pairs, that's fine. Okay, but I always try to figure out if there's a perfect square in there. Any questions on that? Okay, you guys try this one for me, please. You have to use this one. See, Dad, there's no one.
I
Huh?
don't know how to do it. I can't do it. I can't. I'm telling you, I cannot.
Well, then you need to start bringing one, huh?
Yes.
Okay. You need to bring one then. Quit. So now there's a second.
Yeah.
Pull it out. That's good. That's a good thing. Okay. Beautiful. So for every pair, comes out. This pair, well, no, for this pair, when we had the pair of five. Oh, that's okay. Go out front.
I did it.
Yeah,
we did one together. I gave you the half. I did. See, I gave you guys. And I gave you.
All right, good job. You guys are doing really well. Now, let me show you a few tricks. All right, so using this calculator, all right? What's 2 plus 4 plus 3? 9, right? If you add the digits of a number and it's a multiple of 3, 3 will go into it. It also works for 9. If you add the 3 digits and it's a multiple of 9, 9 goes into it. Okay? If we do 3, that's 81. And then I'll circle it. Why? What did I say I circled? Perfect square. Isn't 81 a perfect square? 9 times 9, right? So what number can I pull out? 9. And then what's left? 3. Okay? You could have gone 243, and since they added up to 9, I know 9 goes into them. And then you could circle that. I got a pair of 9s, so what can I pull out? 9, right? And what's left? The 3. So there's more than one way to do these. You still end up at the same place. So far, so good? Okay. Questions? Okay, let's look at that other one. 13 over 25. Now we got a fraction. Okay? So, when we have a fraction, the first thing I try to do is simplify the fraction. Can I reduce this fraction to lower terms? Is there a number that goes into both 13 and 25? No. Now, if it was 15 over 25, what would go into both of them? 5, then I would reduce it to 3/5 and then try to simplify it. Okay? So do that first. If you have a fraction, try to simplify it. Since we can't simplify it, think about it like this. Simplifying the numerator and simplifying the denominator. Okay, can you take the square root of 13? Are there any factors for it? No, there isn't, right? It's a prime number, 1 times 13, right? You knew prime numbers only have 2 factors, right? One in itself. What about 25? That's a perfect square, right? So this one's pretty easy. That would reduce or simplify. Is it okay to have that? Remember, are we hitting the 3? No radicands have perfect square factors other than 1. No radicands contain fractions. No radicals appear in the denominator of the fraction. Did that meet those 3 criteria? No radicands in the denominator, no radicals in the bottom denominator. No perfect square factors other than 1. So we're okay, right? All right, try this one. AJ. Where are you coming from? Oh. So you've been here all day, right?
Yeah.
Okay. What's going on there? Thanks. We done with that one? All right, so what happened here? What did you do first? Simplify? What goes into both? 8? Oh, okay. So what's 72 divided by 8? 9. What's 32 divided by 8? 4. Oh, those are nice numbers. Why? They're perfect squares. So what's our answer? What's square root of 9?
3.
Square root of 4? 2. Nice job. Okay, let's try one more.
For attention, please. Sophomores, last names starting with I through P. Please go to the Performing Arts Hall now for your picture. That's sophomores, last names starting with I through P. Please go to the pond now. Thank you.
Okay. Can you simplify this one? No. So we're thinking of it like this then. Are we allowed to have that radical 7 in the bottom? No. All right? So we have to do what we call rationalize the denominator. Okay? The square root of 7 is called an irrational number. When I write that as a decimal, it goes on forever. What's the most famous irrational number? Pi. Yeah. It goes on and on and on. Never repeats, never stops, right? Well, that's what happens with square root of numbers that aren't perfect squares. You get a number that just keeps on going. Okay? So they have to, what we call, rationalize the denominator. And the way they do that, or we do that, is multiply by the square root of 7, whatever is that in that denominator, over itself. What's anything over itself equal? 1. So it's like multiplying by 1, and any times 1 is itself, right? So we're just going to look different, so we're really not changing it, we're just rationalizing the denominator, getting that radical out of the bottom. So what's 5 times 7? 55. And what's 7 times 7? But what is the square root of 49 now? 7. So this is the answer, excuse me, to that type of problem. We'll have to rationalize the denominator. Get that radical out of the denominator. All right, any questions? All right, I have another worksheet for you to do. It has a couple of the same examples we did on it, but there's 12 problems. Do there. I think there's 5 there. Do there. You have enough? All right, good. We still need one for Nolan.